Histology for you. I know you love that stuff. So, let's go through the kidney. Start big and get small. So first off, you're supposed to name the organ. You're supposed to say kidney, right? So what we're going to do is we're going to work from the outside and work our way in. So let's start with number 23, the outside of a kidney. Capsule. So let's name layer B. What would you call that outer edge? Cortex. What would you call area A? Medulla. So just like your lymph nodes and all those other things, you have an outside, an outer, and an inner. So capsule, cortex, medulla. Okay, then the problem is naming the stuff that's in those layers. So let's name these bright red things which always appear on exams, number 7. Pyramids, or renal pyramids, because they look like a triangle. All right? Then we're supposed to name the tips of the pyramid. So let's look at number 6. What would you call a tip of a pyramid? A papilla. Apex would be nice, but they do papilla. So my renal pyramids are in the medulla, but they contain a papilla. Then you want to think of Egypt, right? Egypt has pyramids and columns. So you look at the area between the pyramids, like number 22. What would you call that area between the pyramids? The renal columns. So I have pyramids and columns that go around the medulla. Make sense? Okay, let's now name this middle stuff.
Sinus.
So what would you call number 4? Pelvis, or you can say sinus. Technically, sinus is the whole pelvis is the spot, but that's your renal sinus. But you notice it has branches, 5A and 5B. So which one is smaller, 5A or 5B? So what would you call a smaller thing in your kidney? Minor calyx or minor calyx. What would you call 5A then if it's bigger? Major. So there's like a gutter system. The fluid's draining down and goes in the smaller tubes first, then the bigger tube second, then the really big pond next, and then down the huge tube number 3. What's number 3? Ureter. That's the one that's going to carry it to the bladder. Right? So you have your papilla, your minors, majors, sinus or pelvis, ureter. That's basically the main structures in there. But then we have a problem, because we also have the red and blue stuff you're supposed to name as well. This is actually not the best model to do that. The model that's in the windowsill you should take a picture of is actually the best model to do. But I'm going to do this. I'm going to change the models here. All right. So what you want to do in your college career before your next test is learn the order of the blood through basically the kidney. If you go on the page, which I don't know what page that is, it doesn't have a page number. They give you the order basically for you. But let's go through it. So number 1, it's a red thing to my kidney. What is that going to be? Renal artery. Then the rule is every time it splits, you're going to give it a new name. So this thing here, segmental. Then it starts to split again. So let's do, for example, let's do this one. It goes up and it goes between the pyramids. So how would you say that?
Interlobar.
Interlobar. They're lobes, so they're interlobar. And then if you notice, like at number 5 here, it comes up and then it curves or makes an arc. Arcuate. And then it goes up again. You can't see it on this model, but it goes one more time outwards. How would you say it? Cortical radiate. So if you think about what that means, cortical means cortex, radiate means to radiate out. So I went renal, segmental, interlobar, arcuate, cortical radiate. Was how I got out there. Right?
Are all 3 of those branches down there interlobar branches?
Yeah, they're supposed to be.
Okay.
Then you're going to turn around and go backwards on the veins. And you're going to repeat your language in reverse. So there would be a blue thing up here that goes down, which would be which one? Cortical radiate. Then it would curve. Arcuate, and then it'd go down, interlobar, and then, no, there's no segmental, believe it or not, so you can't do that one, but you can do renal. Right. So you would learn one way going in and just reverse it with one difference going out. But basically, every time you split, you're going to give it a new name. Right? So thou shalt know the pathway of blood, thou shalt. Right? Let's go back to the other model, since it was there. This shows the same thing, just not, I think, as clearly. So let's start with number 2. What's number 2? Artery. So what would be this first? They don't label it, but what's that? Segmental. Now we're going to go to here. Then we're going to go there. And that. Very good. And then you do the blues, 17, this one, the same way back. So practice going in, turning around, and coming back. Make sense? So we have our pyramids, we have our columns, papilla, we have our blood vessels, we have our tubing. That's pretty much most of the kidney stuff that, at this level of detail. So what we're going to do is we're going to zoom in on a pyramid. So we're taking one of the triangles from Egypt, right here, and we're zooming in. Okay, remind me what 23 was. Very good. Remind me what B was. Oh, good. And so what would all this be then? Oh, yeah, medulla, yeah. Okay. So here's the problem. So now you're going to notice the blood vessels. So remind me again what this blood vessel here would be, number 25. Interlobar, because this one is the curve of the arcuate, cortical radiate, right? So we're just zooming in. So what you want to do is look at number 9. That one's coming from the cortical radiate and going into this funny thing. So it's going in to my nephron. How would you say in? Afferent arteriole. So that would be the afferent arteriole. Oh wait, here's one coming out. How would you say out tube? Efferent arteriole. So when you zoom in, you can start seeing the ins and the outs. So now here's the next thing we have to figure out is the white tubing. That's the nephron. So you notice there's different nephrons here. So what you're going to do with your finger on a test, you're allowed to do this, is take your finger, start there, or there, and take your finger and literally track it. Because what people will do by mistake, I was a student, they'll say, oh, the thing on the right's descending. The problem is this one's the mirror image of that one. On that one, it's the ascending, if you do the right one. Right? So don't memorize it's the right and the left. Take your finger and track the fluid. So we're going to start here. I'm going to go through this squiggly tube that's near that. So how do you say squiggly tube near something? Proximal convoluted tubule. Then I'm going to go down a tube. What tube am I going down? The descending loop, or descending loop of Henle. Then I'm going to turn and go up, which would be ascending loop. And then, hey, here's another squiggly tube over here. Distal convoluted tubule. And then I'm going to collect with everybody else in the collecting duct. So PCT, descend, ascend, DCT, collecting duct. Right? Just track the fluid, yes. Kind of yes. But you want to just do direction in a quiz. No overanalyze it. So on this one, because it's a mirror, this is the descending on the left and ascending on the right. It's still the same relationship. So you're going to start with the proximal, go descend, ascend, distal, and out. Make sense? So literally take your finger and you show, it's like your colon, right? If you follow the poop, you should get it right. That comes out wrong somehow. Right? Okay, so then what we're going to do is look at the blood vessels a little bit more. And that is, you have different blood vessels here. These blood vessels are surrounding the tubules. So how would you say around the tubule blood vessels? Peritubular capillaries. Very good. But here are blood vessels down here, which would be around the loop and the collecting duct. Those ones are your vasa rectas. So you have peritubular capillaries in the cortex and vasa recta in the medulla. They're basically the same kind of thing, just different location. Make sense? So now what we're going to do is we're going to zoom in some more on the that thing right there. We're taking one of those circles and zooming in. On the boards is that. That is the beginning of one nephron. Look in the upper right corner, you'll see the name of that thing. That whole thing on the picture is called a what? Corpuscle. So corpuscle is everything you see here. That is a corpuscle entirely. Right? But the corpuscle has things in it that thou shalt know. So let's go through our thing. So let's start with the easy one. Number 6. That's blood coming in. Afferent. So number 7 must be blood going out, which is? Efferent. Okay. Now we're going to name the tubing. So the fluid would start here and go this way. So on the other model, what was the first tube after the circle? Proximal convoluted tubules down here. It would go down, come back around, and this would be the one near the outside. Which one's number 11 then? Distal. So you have your PCT and DCT, your afferent, efferent. That leaves number 8 and 9. So what is 8 and 9 together? Glomerulus. The glomerulus is the blood vessels in there. But number 9 has something on it that number 8 does not. Podocytes, or foot cells. So you say podocytes, it sounds fancy. So these are podocytes that are on top of the capillaries on number 8. Right? They would both be at both sides. So those are your glomerulus. So tell me what number 10 is then, Smarties. Capsule, or Bowman's capsule. So here's where life's going to be problematic. There's a capsule on the kidney called the renal capsule, and there's a capsule here called the Bowman's capsule, or nephron capsule. So if you say capsule on a test next week, I'm going to scream at you in red because I don't know which capsule you mean. So make sure you either put renal or Bowman's, or renal and glomerular, something that tells me, there's a difference between the two capsules. Capsule just means outside, right? So renal is the kidney capsule. This is the Bowman's or nephronic capsule, or glomerular capsule. So if you think of this as looking like lungs to some drunk Roman, you had a chest cavity, right? What'd you call the outside layer of your chest cavity?
Parietal.
The parietal. So number 10 is the parietal layer. So therefore number 9 must be which layer?
Visceral.
The visceral layer. And then what do you call the space or between the layers? The lumen, a capsular lumen. So if they view a chest, parietal, visceral with lumen, but in this case, the Bowman's capsule is the parietal, the podocytes are the visceral, but they still make those layers. Make sense? And all of that's a corpuscle.
Is there visceral on 8?
Well, in theory, that would be the visceral, but there'd be a podocyte there normally.
Okay.
So now the problem is number 13. This is the one that's going to bother you. Because 13, you notice, has two parts, a 12A and a 12B. All right, so here we go. If you include 12A and 12B together, that's the juxtaglomerular apparatus that we talked about in class. So 12A plus 12B is the apparatus. Juxtaglomerular apparatus. Near your glomerulus. Right there. But wait, there's more. Because 12A and 12B individually have different names. So 12A is called your macula densa. Those cells, right here in the yellow, those are the macula densa cells. They're not the juxtaglomerular apparatus. They're the cells. 12B are juxtaglomerular cells, not apparatus. And that's where it's pointing here. So you have macula densa here, juxtaglomerular cells here. Put them together, they're juxtaglomerular apparatus. Make sense? So on a quiz or test, be careful for asking just 12A, just 12B, or both together. Right? Because there's a different name. So apparatus is both, macula densa and juxtaglomerular cells are individually. Remember lecture, this is for the blood pressure and the salt monitoring. Right? So be careful. Classic questions, forget which ones are cells and which ones are apparatus. Apparatus is the bigger one. Everything. Make sense?
Yes.
Okay, then just to confuse you, there's another juxta word. Has nothing to do with this. But we love to ask it on exams just to watch you cringe and hate us. Look at the nephron on the right. Compare it to the one on the left. Which one's longer? On the right. And it's long enough that it goes near my medulla. So how would you say longer nephron that goes near my medulla? Juxtamedullary, meaning near my medulla. So you have a juxtamedullary nephron is the longer. The juxtaglomerular is the little cells in the corpuscle. So don't let the J word throw you. They're different J's. Make sense? All right. That's pretty much most of the kidney. And we'll do histology a little bit. Let me get you some bladder pictures. I know you love that stuff. Bladder. Ooh, here we go. Actually, all right, so we did kidney. Tell me tube number 2. What was this tube 2? Ureters. What's 3? Bladder, okay. And there should be a tube coming out of number 3. Let's zoom in on that. What's tube 4? Urethra. So now we have some language to learn. One of my favorite words, second to rugae, is what number 15 is. Do we know what 15 is? Nope. Trigon or trigony. The way this works is you have one hole from your ureter here, one hole from the ureter there, and a hole for your urethra there, which makes 3, or a triangle. So trigon or trigony. That's the base of your bladder where the 3 tubes come out. 2 uretic orifices and the urethral orifice. It makes 3. I always put that on an exam. Okay? That's your trigony or trigone. You can say it either way. That's in the bladder. All right? So I'm trying to think if there's anything else in the bladder you're supposed to know. Uretic orifices we got. Trigony we got. Bladder, you're good. Good, good, good. I think you figured that out. Okay, let's go through your urethra. We're supposed to figure out the differences in the urethra. So let's find naked men. No one ever responds to that. Okay, awkward silence. That's this guy. All right, so in a male, we break down the urethra into other parts because there's more parts to name. So here's my bladder. So if you look here, this is my urethra, or some guy's urethra. All right, so you're going to name this part here. So what do you call the part right in there? Prostatic, because it's in my prostate. The little bit right here has a name, membranous, and then everything from here out is penile or spongy. Either way is fine. But then we have some other things to name, which is this one, number 11. There's a red line right across there. What is it? No, it is, but it's not. That's called your urogenital diaphragm. In English, this is the muscle that holds your genitals on or in. So it goes from your pubic bone back, and that's like a diaphragm with your lungs. That's your urogenital diaphragm, it's the red line. Right? And that separates kind of your bladder from the exterior stuff. All right? On a girl, we would also find that part, but because you have less kind of hanging out, it's a little different. Okay. Let's find some girly parts. On a girl, number 16, what is that called? It's just called urethra. You don't have to name the parts because there's only one tube. And the urogenital diaphragm is this red line here. So it's a slightly different location. But so women have one urethra, men basically have 3 parts to one urethra. Other than that, it's pretty easy once you get the bladder. Make sense? Okay, let's do some histology. The easiest slides you'll see. There's that. Let's go find J-Doc. Where's my J-Doc? And let's do urinary. And we want to do... All right, so on a lab exam, your first goal will be name the organ. And so hopefully you're not going to say stomach. It'll make me mad. But you're going to say, that's a kidney, Mr. Christie. I'm going to say, well, how did you know that? And that's my question. How did you know that was a kidney? What are we looking for? What is it? Glomeruli, or the corpuscle. So each of these circular areas is a corpuscle, those round things, with the glomerulus in the center and the Bowman's capsule around them. So if you see that fist in hand kind of thing, we call it, those are corpuscles that has to be a kidney. So you're looking for those balls. So we're going to zoom in on those balls right here. That's one glomerulus, one corpuscle. So the corpuscle is everything you see on the slide. If I point to this, you say glomerulus. Point to this, you say capsule, Bowman's capsule. That's the lumen or the sinus, right? Parietal, visceral. That's the one. So if you can do that in your head on the slide, that's cool. So kidney, glomerulus, corpuscle, all that. Make sense? Okay, Smarties. Let me get you this one. I love this slide. I don't know where they got it. It's fantastic. Because what's all this stuff? Anyone know? Red blood cell. That's showing the blood going into the glomerulus to be filtered or coming out. So that just shows you, again, there's blood vessels in there. But again, I can see the corpuscle. The other thing you can see easily on the slides are these kind of things. What do you think those things are?
Fat?
Nope, looks like fat, but not.
It's like some kind of mucus or watery kind of slime stuff.
Nope.
Is it a cross-section of the two?
It's a cross-section of tubules. Those are the tubes that are carrying the urine up and down. That's not the glomerulus, the corpuscle, that's the tubing. So if I go back to, say, this slide here, that's a kidney, and I'm looking at all those little nephron tubes in cross-section. So the urine's going in and out of the screen, basically. Right? That's in the medulla. If I go to the cortex, where all the nephrons hang out, more so, like that, I can see the glomeruli and the corpuscles, but I also see the tubes. Those are all the tubes. So you have to identify tubules when you see them.
What's that dark spot up on the top right? The really dark circle.
Beats me. I see. I don't know.
Okay.
Some kind of weird spot. I don't know. So you have the corpuscle kidney tubules. And then the other thing you're supposed to know, even though we don't have slides of it, you're supposed to be able to identify the tissues in the rest of the urinary system. So this is a slide from 231, which hopefully you know better than 112. And what would you call these cells here? I heard it. Transitional epithelium. So what parts of your body have transitional epithelium?
Urinary
Bladder, ureter, yes, where I get stretched. So that's actually a ureter because it's star-shaped. But so you have to identify transitional when you see it in a ureter or a bladder. But we don't have slides of a bladder or a ureter. You still have to be able to figure out that that's transitional. Right? Let's see. So transitional is on the right, so that's where the P is. Right? This is kind of a bladder they're cutting through. So if you know transitional when you see it, if you know, like here's another close-up of the bladder wall. Right? So if you can do transitional and tell me where it's found, you can find the corpuscles and name what you see. You know, it's a kidney and tubule. That's pretty much the histology of the kidney, the urinary system. The rest of it's pretty much on the models. Make sense? That's pretty much kind of all for urinary anatomy. The next week you take your one. So kidney, right? Ureter, bladder, urethra. So if we go to our kidney, so I know the outside is the capsule, which is the brown part. The cortex is the outer, lighter edge layer region. And the medulla is basically in the middle where the pyramids and everything live. And in the very, very middle would be the sinus or pelvis, which is where the urine collects. If I take this and make it bigger for your photographic pleasure. All right, so again, I have my capsule, renal capsule, cortex, medulla. In my medulla, I have the renal pyramids, which are the triangles. And they have a papilla, which is the tip, basically. Between the pyramids are the columns. So column, pyramid, column, pyramid, column, pyramid, column, pyramid. And then, as I go downwards, in my sinus or pelvis area, I have the minor calyx, or calyces, which are the little forks that would collect the fluid, here and here. They become bigger, which would be majors, right about here. And the majors, like in baseball, all meet together. So your minors to majors to the pelvis or sinus, out the ureter. Then I'm going to do my blood flow. So, if I start on number 2 here, which is the renal artery. I go in, the segmental is the first one that comes off. And then I'm going to turn and go up between the pyramids or in the columns. That's called interlobar, because these are considered lobes. I'm going to turn and become arcuate. Then I'm going to go out further, which is the cortical radiant, also called the interlobular is another word for them. And then I'm going to turn around when I do my stuff and do veins. So cortical radiant vein, arcuate vein, interlobar vein, but there's no segmental. I just go directly into my renal vein. On this model, I would do the same thing. Renal, segmental, interlobar, arcuate, cortical radiant, artery, cortical radiant vein, arcuate vein, interlobar vein, renal vein. All right. Then, if I take one of these and put it here, so this would be my pyramid with capsule, cortex, and medulla. Again, my interlobar, arcuate, cortical radiant. Then I would have an afferent, which is the one going from the cortical radiant into my corpuscles, which are these circles. Then my efferent are the ones coming out of my corpuscles, going away. So here I'd have my cortical radiant artery, my afferent arterial, efferent arterial, my peritubular capillaries, then to my cortical radiant vein and out. The veins down here are called the vasa rectas. Those would go over these ones. And then I have the white things, which are the corpuscles. I'm going to follow the fluid. I'm going to start at my glomerulus. Then I got my PCT or proximal convoluted tubule. Then descend, loop of Henle, ascend, loop of Henle, or nephron loop, distal convoluted tubule. Then I'm going to collect in the collecting duct out the papilla. This one would be the same over here. And then that becomes this. So one corpuscle is this. So in my corpuscle, I'm going to have the glomerulus, which is this part, and the Bowman's capsule, which is the outer part. So I put that in there. I have my afferent, which has the muscles on it, coming in through the juxtaglomerular cells here into my glomerulus, which is covered with podocytes, which are the visceral layer. Then I have my lumen, and then I have my parietal layer of my Bowman's capsule. The fluid would then go down the PCT, which would be this, go all the way around, and then come back out my DCT, which is here, which has the macula densa cells, and then head out. So afferent, efferent, juxtaglomerular cells, macula densa cells, apparatus is both, podocytes on the visceral layer, Bowman's capsule on the parietal layer, with the lumen in between. Make sense?
Those podocytes are on that as well as on the right.
They would be. They just removed them
Right,
to show
they
you
just-
capillaries and the fenestrae.
So it's going out and back in before it goes into the
Yes.
collecting?
It goes by it. So it leaves the blood here. And then remember that the kidney has to check not only the pressure of the blood going in, but the saltiness of the blood of the urine coming out. So this is where in lecture, this is my GFR controller for the pressure. This is my GFR controller for the saltiness. So it has to check the fluid before it hits the urine, before it actually leaves the nephron. So between these, your kidney can control the GFR by knowing what's coming in and what's going out.
So where does the filtration,
Filtration would be from here, blood to nephron.
okay, and then the reabsorption,
Those would be in the tubes down in here, which we haven't gone over in lecture yet.
and then the secretion?
Would also be in
right
those
there.
tubes, yeah.
So is there a mechanism when the osmolarity is tested here for
Mhm.
it to, instead of cycling back out into the collecting tube, for it to go back through another cycle?
Nope.
Is that something that would happen, or is
Nope.
it just sampling and
It's just
adjusting
sampling and then
accordingly?
adjusting the next round.
Okay.
So you're constantly leaving that stuff leaving, and what you're doing is the stuff that's leaving, you're trying to adjust what's coming in.
Okay.
So there's a delay. Yeah. Otherwise, you'd basically be sending your own urine back
Yeah, you'd
through,
just
which
be going in the
wouldn't be
tubes.
doing you very much good. More thing on this one I forgot. And that is, this is called a cortical nephron because it's mostly in the cortex. This big long one is juxtamedullary nephron because it's longer down the medulla, not to be confused with juxtaglomerular, which is over here. Then we're going to go down to our bladder. So if I leave there, go down my bladder through my ureters, through the uretic orifices, into my trigon or trigony, which is the triangle. Then I go down my urethra orifice in my urethra. The bladder would have the detrusor muscle, which is the main one you see. If I'm a male, which I am, I have my prostatic urethra, membranous urethra at the corner, and my penile or spongy urethra. The urogenital diaphragm is right there. In a female, there's just one tube, so it's urethra. And this one doesn't really show very good urogenital diaphragm, which is right about there. And then worthless trivia. The internal urinary sphincter is always at the neck of the bladder, here. The external is your urogenital diaphragm. So males, your external would be there. Females, your external would be roughly there. And that's involuntary, involuntary. I'm sorry. Yeah, involuntary, involuntary. Yeah.
Is that, just out of curiosity, is that membrane you're talking about?
And the bladder end of town. So ureters coming in there, uretic orifice. This would be part of the trigony or trigon. Urethra orifice through the prostate. You can't really see the curved spongy urethra. So just it's another way of looking at that picture. Nothing necessarily different. Let's see, what else? I'm trying to think if there's something. Nope, I think that's all.